Okey, kelas akan mula sekejap lagi ya. Saya masih menunggu yang lain sebab saya takkan accept untuk orang lain join lepas ni sebab ialah dia akan mengganggu perjalanan kelas. Okay, who are not join the class, please ask your friend to join it because we're going to start our class soon after this. Okay. Assalamualaikum dan selamat petang semua. Our next meeting. Okay. I have to finish our lecture on chapter 3 because all of you going to have the midterm test. So today I would like to give a lecture and finish on the second part of the chapter. So there are actually two important things that we're going to learn. Okay, two topics that we're going to learn in chapter 3 part 2. The first is regarding asymmetric and symmetric encryption, and the second one is regarding an algorithm. Actually, we're going to learn regarding RSA, and the last one, or the third topic that will be covered for this lecture is going to be on Diffie-Hellman. Okay, so for tomorrow midterm test, it will be conducted and during night. I would like to explain to you, okay, regarding the midterm test. Okay, the topic that will be covered for midterm test will be from chapter 1 until chapter 3. Okay, and the most interesting thing is half of the midterm test question, assuming that the total marks for the midterm test will be 50. Okay, will be 50, and 25 marks from it come from chapter 3, cryptography, which means that half of the midterm test will the question will be asking regarding cryptography. So hopefully, okay, you manage to understand all the techniques that we have learned before and the techniques we're going to learn today, because it contribute 25 marks, half of it. It's a lot actually. And another 25 mark will be covered from chapter 1 and chapter 2. Chapter 1 is regarding the introduction of DNS, data and security. Most of it is regarding the terminology that we are going to use usually in these courses or syllabus, which is the CIA threats, right? The threats, the vulnerability, okay, the risk, okay, and other type of terms like redundancy and others. So you have to remember, understand Okay, for each of the term, what is it and how you would like to implement and apply it. Okay, for the second chapter is regarding the awareness, okay, ethicals, the act, and most of it is on the theoretical path. So you have to read all the things for chapter 2. Okay, understand what is a digital diversity and what are the analytical tools that has been used, okay, in chapter 2, and then the act that has been applied in Malaysia and other countries, okay, and how you would like to behave when you are dealing with the uh, a data that you would like to say is a confidential and you have to protect it. Okay, that is a chapter 2. So all of the students have to read chapter 1 and chapter 2 lah. And these in the midterm test will contribute 25 marks. Okay, and another 35 marks will be asking from chapter cryptography. Okay, so today I would like to finish the lecture on cryptography. Next day, tomorrow in the morning, okay, we're going to have a class. Okay, we're going to do some exercise regarding it. Okay, so for the midterm test also, there will be no bus or transportation will be provided to the student to come to our faculty to sit for the test. So you have to manage, and then you have to manage your own transport, okay, to come to the our faculty to sit for the test during at night from 8 to 10 p.m. tomorrow. Okay. So, without further ado, I would like to continue our lecture. Okay, on chapter 3, cryptography, part 2. So, on the part 1, we have learned, okay, a few types of techniques and terms that we'll be going to use in cryptography, like the plain text, what is hypertext, what's a key, right? And terminology for cryptanalysis, and then we also learn regarding classical techniques. Okay, there are two type of classical technique that we have learned. The first one is a substitution, and the second one is transposition. Again, what type of cipher that falls on the substitution cipher, or what are the cipher or algorithm that falls under the transposition cipher. Okay, so we have finished it already on the last or previous lecture. Okay, the last classical technique that we learned, okay, on our previous class is the last on our previous class is columnar transposition cipher. However, today we are moved to the modern cryptography. Okay, modern cryptography or techniques. Okay, that will be implemented in the calculation march on the mathematical calculation. Okay, before that, I would like to explain again, recall back what is asymmetric and what is symmetric encryption. Okay, because I think on the previous class also I already mentioned, okay, regarding it. So for the symmetrical encryption or symmetric, okay, in a symmetrical encryption, we know that they are sender and they are receiver. Okay, both sender and receiver would like to communicate and would like to exchange the message to each other. In a symmetrical encryption, both communication will be encrypted with the same key. That is a symmetrical encryption, which means that, okay, for example, A and B. A is the sender, Alice, and the B is the receiver, Bob. Alice will send an encrypted message that will be encrypted with K to Bob. And then Bob, we're using the same key is K to decrypt the ciphertext to get the original message. Okay, that is a symmetric or symmetrical encryption. So, what are types of algorithm or has been implemented by these symmetrical encryption, for example, such as a Blowfish, AES, RC4, DES, RC5, and RC6. Okay, this is the widely used symmetric algorithm lah. Okay, that's been used right now. So, what is asymmetrical encryption? Okay, the difference between asymmetrical encryption and a symmetrical encryption is only for the key that has been used. In the symmetrical encryption, they'll be going to have only one key. Okay, only one key that we're going to use to encrypt and decrypt. It means that they're going to use the same key for the whole process. However, for the asymmetric, it's something different. There will be at least two key. Okay, the first key is the public key, and the second key will be the private key. In this type of encryption, okay, the public key will be shared to each other. However, for the private key, will keep for each other. For example, in this type of encryption, Alice and Bob. Okay, Alice would like to send a message to Bob. Okay, what Alice do at the first step? They have a plain text, and then Alice have a public key, the first key. The public key is a key that has been agreed by both parties and they share to each other, Alice and Bob. Alice will use this public key to encrypt the plain text, okay, into a ciphertext. Then Alice send the ciphertext to Bob. Bob received the ciphertext. What did he do? Okay, he would like to know the original message that has been sent by Alice. And Bob decrypt it back with a private key. Here, private key means the key will be kept secret only to Bob. Alice will not know what are the value for the private key that has been used by Bob. Okay, so Bob used private key to decrypt back the ciphertext, and Bob can read the original message that has been sent by Alice to him. Okay, that is the meaning of asymmetric encryption. So setakat ni boleh faham ya? All of you? Boleh?
Boleh sir.
Okay, boleh. Alhamdulillah. So kita kena betul-betul faham supaya kita tidak keliru lah. We not get confused. Okay, we can differentiate between the public key and the private key. Okay, so this kind of encryption actually has been implemented in a public key crypto system. So the next slide, okay, you can read it by yourself and you will get the idea how you would like to implement, where you would like to implement the public key and where you would like to implement symmetrical encryption or the asymmetrical encryption. Okay, now we move to the modern type of cryptography. Okay, one of the most important things you should know. Okay, for your preparation for the midterm test and for the final exam, because these two type of algorithm, okay, always come out in your final exam or the midterm test. Okay, the first one is regarding, okay, this is a public key crystal system, sama saja, same that I have been explained to you before. I just keep it. Okay, we move and I would like to explain regarding the RSA algorithm here. Sekejap ya. Okay, if you look here on this slide, okay, this slide is regarding RSA. RSA is an encryption, a public key encryption technology developed by RSA Data Security. The RSA algorithm is based on the difficulty in the factoring very large prime number. Based on this principle, the RSA encryption algorithm use prime factorization as the trapdoor for encryption. So RSA is based on the calculation, mathematical calculation. Okay, the main of the RSA, okay, they implemented the public key encryption, which means that in the public key encryption, there is a public key and there is a private key. Meaning there are two type of key that going to be used in this algorithm. One is public key that has been shared by both of the parties. Okay, Alice and Bob know, okay, regarding the public key. However, for the private key, it will be kept secret for each other, which means that Alice will not share her private key to Bob, and Bob also will not share his private key to Alice. Okay, so the another I mean that the main in the RSA is regarding factoring a very large prime number. Okay, in RSA they implement a prime number in this algorithm. Hopefully you still remember what is a prime number. Okay, semua masih ingat what is a prime number Masih ingat lagi ya? Ingat.
Ingat. Ingat.
Okay, terus. Prime number is a number that only can be divided by itself or 1. For example, 2. 2 can divide by itself, 2, and 2 also only can be divided by 1. Other number, no, because there will be a fraction over there. Okay, so apa yang kita buat? Other example of prime number is 3, 7, 5, 11, 13, and other and so on. Okay, and the other main thing in RSA is regarding the factoring. Okay, factorization, which means that the factor of the prime number. If in the RSA we choose two prime number, 2 and 3, what is the smallest factor for 2 and 3? Someone can answer it?
1.
Are you sure? What is the smallest factor? Factoring is something that factorization, gandaan, the factor where they can meet at a point, this number are factory to each other.
6.
6, okay? 6. Other than 6? Greater than 6? What? The next number of 6 for 2 and 3. 7? No. 9? No. 8? No.
12.
12.
12. It should be 12. Okay. Alhamdulillah, semua faham. Okay. So RSA is named after Ron Rivers, Eddie Shame, and Len Edelman. So these three inventor or a brilliant guy who create this algorithm. Okay. Why? Because they would like to propose a new type of algorithm to make sure that when they communicate to each other, okay, A and B communicate, how they would like to protect, okay, the value and of the message itself. So RSA algorithm can use for both public key encryption and digital signature. Okay, its security is based on the difficulty of factoring large integers lah. Okay, digital signature will implement this kind of RSA algorithm lah. Okay, so prime number, this is explain what I have already mentioned to you before. So we move the step in RSA algorithm. Okay, hopefully all of you can pay attention on this slide and listen it carefully. Okay, this is, if you see in this slide, okay, this is the step that we're going to use if you would like to apply RSA algorithm. Okay, in RSA algorithm, okay, there are two integers. The two integers. The first one is P and Q. Usually P is a prime number that you choose, and P and Q is a prime number. Both are the prime numbers actually. Okay, both are prime number and must not be the same value. Okay, and then we choose the value for P and Q. After that, we have to calculate the value of N here. See here, the value of N. This is the value of N. How will you calculate the value of N? P multiplied by Q, you will get N. Okay, this is how we calculate by N. Very simple. For example, if the P is 2 and Q is 3, so the value of N will be 6. Okay, after we calculate the value of N, we have to calculate the value of totarian n, totalian n, or maybe I would like to totalian n. Okay, how we will calculate the totalian n? Okay, this is the formula of it. P minus by 1 multiple with Q minus by 1. Okay, for example, P is 2, 2 minus by 1, we got 1. And then Q is 3, 3 minus by 1, we got 3. So 1 multiple with 2. So the totalian for n will be what? So what the
Two.
answer here? 2.
Two.
Okay, 2. Okay. So after that, we have to select an integer, E. Integer E is actually a public key. We can say that it's a public key, which means that both party agree and both party will use this. I mean that the E will not keep secret. Okay, the E will not keep secret and both party agree to use this key. Okay, how you calculate the E? Okay, we must know E is must greater than 1 and E also must less than totally n. You can choose any numbers. Okay, you can choose any numbers. However, this is the term for E. E must bigger than 1 and E must less than 1. So kalau kita guna tadi, for example tadi kan, E tadi, totalian totalian n is equal to 2. So E must less than 2. Tapi you must be careful lah. And then E must greater than 1. So E, the number of E may be 2. You can choose 2. That is for the value of 2. And then we move to another step. We have to calculate the D. Here, D is the formula. However, for D, we have a different formula that much easier. I will explain to you how you would like to calculate D after this. Okay, compare with this is very difficult to calculate. Okay, to calculate it using your calculator also is very difficult. So we have another formula to calculate it. Okay, and then the another step, from there we get the public key. Okay, what is a public key? We already know E, agreed by both party, and N is what? The multiple for P and Q. So this will be the public key. Okay, A and B will share this value to each other. However, for the private key, okay, which means that it will be kept secret. Okay, only one of the side will know what are the private key and going to use it. Okay, so PRD, this is where we derive the D, and N is the number of multiple by P and Q. Okay, so encryption by Bob and Alice public key. Okay, the plain text is M. So this is the formula if you like to calculate a ciphertext for the message. C, the ciphertext, equal to M, the plain text. Okay, power by E. E is the key that you choose. Okay, derive key that you choose. Mod by N. So you will get the ciphertext. It's very, for encryption, it's very easy. Okay, because it's straightforward only. However, for the decryption, you have to find the what value of D first. Okay, and D you will get the value by using this for this formula. Okay, so M, the message you would like to, from the decryption, from the ciphertext you would like to get the original message, equal to C, the ciphertext that you have to decrypt, power by D is something that you will get the value from this mathematic formula, and then mod by N. So from here, you will get the message by the original message. To explain, to make sure that you understand it well, let's we move to the, to the example of it. I will share to you the example. So, let me see here the example. Tak nampak eh? Okay, see. So, this is will be the example. Okay, this is one of the, I mean the question. Okay, the question in the final exam or the midterm test. Okay, regarding RSA. Okay, this is how the student will be asked. Okay, how you would like to answer, how you would like to tackle this kind of question. Okay, hopefully all of you will manage to understand it well from here. So the question is given a plain text. Do this on your own. Buat sendirilah. Maknanya lepas ni saya takkan tolong lah. You kena buat sendiri. Okay. So what should you do? This is the plain text. Encrypt the message using RSA algorithm with P equal to 5, Q equal to 11. So P and Q has been provided to you already. And you know that P and Q is what? P and Q adalah apa? What is P and Q? P and Q should be what?
prime numbers.
Prime
Yeah,
number.
P and Q should be a prime number. Thank you to all of your friends who answer it. P and Q should be a prime number. And the public key E equal to 7. Okay, this information has been provided to you. Okay, so you don't have any problems, okay, regarding it. Okay, kalau lah in the final exam or the midterm test, they didn't provide it, you have to think it for yourself. What the value for Q, what is the value for P, and what is the value for E. So in this question, they already provided to you. But however, you have to show step by step, okay, to solve this problem, to encrypt, okay, and decrypt. Yes, ada orang nak tanya soalan ke?
Yes, Professor. I'd like to ask how we can get the P and Q by ourselves if not given in the question.
If not given in the question, you know that P and Q is a prime number. You can choose any prime number. Okay, you have to try and error actually. Okay, because there is a coefficient between the prime number to solve for the RSA. Not all of the prime number, okay, will be the answer for RSA algorithm. Okay, however, okay, the P and Q is prime number is only for the first step because there is another. Okay, you have to create for the E, you have to know for the value of N, and then for the value of theta N, okay, or not totalian N, okay, and then the value of D. Okay, these value are related to each other. If the prime number, okay, was not related to it, so you can apply this RSA. Okay, so that's why most of the question you will going to provide with the prime number. Okay.
Thank you.
Okay, welcome. So we move to the slide. I mean that to the to here. So this is how the schema, how you would like to step by step. The first, you have to count the value of n. Okay, you know, and the formula is P multiplied by Q. Okay, here in this question has been provided to you. P is equal to 5 and Q is equal to 11. It's very simple. You just multiply it by each of the value, you will get 55. Understand? So n will be equal to 55. And then you have to calculate the totalian n. Okay, the formula for totalian n here, P minus by 1 multiple with Q minus by 1. So you just replace the value, P and Q, and then proceed to the next step, 5 minus 1 times 11 minus 1. Okay, solve in the first bracket, 5 minus 1, you get 6. Sorry, not 6, 4. And then 11 minus 1, you will get 10. 4 multiple with 10, you get 40. So 40 will be the value for totalian n. Understand? Semua? Boleh? However, to get D, D here is a very different formula that has been stated in the previous slide before. Betul? And this is more easier compare with the formula, with the the other formula that I have already shown in the slide. Okay, dalam slide yang in your, I mean that in your uh, course slide for chapter 3 is different here. However, this is how we will like derive to get D. Tetapi in this formula, we have to okay uh, to replace each of the, I mean that each of the value of the parameter. And here we came, we have to assign. Okay, we have to choose another value for a parameter. There is a another parameter that have to add here is k here. Okay, previous in the other formula, kalau kita tengok balik formula yang sebelum ni kan, if you see here the formula, the previous formula here, kalau kita tengok formula sini kan, there is no parameter k to get d. Okay, there is no value for k parameter here. However, kita tinggalkan, we replace how to get d, the formula, I mean the value of d. We use this formula. It's much easier. Okay, here this formula. So the formula to derive the value of d equal to, in a bracket, 1 plus k multiple with totient n. Okay, you will get the total of it divided by e. You know e. E is the public key here, equal to 7. Okay, and then k is something that a new parameter. Okay, that will be multiple with totient n. Totient n here you already know is equal to 40. So what should you do? If k equal to 0, do one by one until, okay, k iterative value from 0, 1 until the result is no fraction. There is no fraction. Bila you, after you get the, I mean that the value of here and you divide by e, there is no fraction, which means that you got a solid number over there. Okay, k equal to 0, you replace the value of each parameter 1 plus 0. Okay, 0 is because of what? K is 0. 0 multiplied by 40, you get 0. And then divide by 7, there is a fraction. And then we move to another value of k, 1 plus 40. 1 is the value of k multiplied by 40, the totally n. Okay, 41 divided by 7, there is a fraction. You move to k equal to 2, there is also a fraction. You move k equal to 3, 1 plus 3 multiplied by 40, you get 120 plus 1, 121 divided by 7, there is also a fraction. Okay, and then we move to another value of k equal to 4. 1 plus 160. Where you get 160, just replace k, 4 times by t, total n, 40, 160, plus by 1, you got 161 divided by 7. By using the calculator, you know the answer is 23. It's a solid number. So when you got the solid number, it means that you already get a value for D. So we can see D is 23. Understand? Boleh ya? So all of you should remember this formula. Okay, kena ingat formula ni. Okay, how to derive D. Understand? Boleh ya? After you derive D, we know that, okay, to get the ciphertext, this is the formula. C, the ciphertext, equal to message power by E, the public key, mode by N. N is what? 55. So you just replace each of the value of the message to got the ciphertext. Here the plain text is do this on your own. Sila kira lah sendiri lepas ni. So you just replace it in the numeric value for each of the number. And then After apply this formula, this is the last value of it. 42 is the ciphertext for D. 9 is the ciphertext for O. 24 is the ciphertext for 3. Okay? Write all the answer, you will get the ciphertext. However, for example, is the in the question, they only provide you this only. Okay? This value of number. They say that, okay, given a ciphertext 42, 9, 24, maybe they will they will saying that 42 is one number, 9 is one number, 29 is one number. And you have to find the original message. So what should you do? Okay, you have to find the value of D. Get the D value and then apply it in this formula. Okay, M equal to ciphertext. Okay, the ciphertext, one of the ciphertext is 42, power by D. What is a D? D is 23. Okay, the D you derive by using this formula. And then you will mod by 55. 55 is what? N. 11 times 5, the prime number that you choose. Okay, this is the prime number, 5 and 11. So after go through with this formula, you will get the last one is 3 and numeric value. So change the numeric value in the alphabet, you will get D. So that is how you solve RSA. Understand? Faham setakat ni? Faham ke? Ke pening-pening sikit dah? Understand. Alhamdulillah. Okay, that is RSA. Okay, that is RSA. So the RSA, you have to remember the step. Okay, what are the formula, the mathematical formula that involve here? How you would like to get the value of N, total N, the value of D. Again, and then you apply all the value in this mathematical formula for the ciphertext, and then in this for in this formula to get the message back. This is RSA. Okay, they involve the public key crypto system because there is a public key that has been shared by each other. E is public key. Both of the sender and receiver know what is the public key. However, for the private key will be kept secret. Okay, to decrypt it. Okay, that is RSA. So we stop at the RSA, and then we move to another type of cryptography that we're going to learn here, a modern cryptography, which is a Diffie-Hellman key exchangeable. Okay. Okay. Timothy, okay, the other slide, you may read it by yourself. Okay, get this also one of the example. You can see here, okay, how they get the I mean the value of D here. Okay, the value of D. Okay, 23. Okay, and how you will get 23? You just apply, okay, this kind of formula, the formula that I've shown you in the previous example. Okay, you can try by yourself and to make sure that you understand. Okay, okay, here, this is the private key that will be sent to what? To another party. KPU. Okay, 7187. It will be sent as an encryption to the receiver, and receiver, if they would like to decrypt to get the original message, they have to decrypt it using the what? A private key 23 is equal to D. Okay, D is a private key for the receiver to decrypt the value. Okay, I mean to decrypt the ciphertext that has been sent by receiver. Okay, you boleh go on through it by yourself. So we move. This is only the explanation how you implement where you would like to implement this kind of public key crypto system. So we move to another topic is regarding the Diffie-Hellman key exchangeable. Okay, key accessible and distribution. In this slide, okay, actually key accessible and distribution is one scheme that combine okay two type of algorithm, which is asymmetric and symmetric. Okay, because of what they would like to solve a problem. Okay, we should know the key exchange distribution or the key exchange or distribution is an algorithm to make sure that the key that going to use by both party is protected, okay, not being modified. And they know, although they know that this key is public, both party know. However, how they would like to know that the key is protected, the key is not being modified. Okay, that's why, okay, to solve this kind of problem, they come with another scheme, another method how to deliver it securely. Although both of the party know that the key will be the same. I mean, the key will be the same and the value are the same. So, Diffie-Hellman key exchangeable. Okay, it was invented by the Whitefield Diffie and Martin Hellman. Okay, these two men come out with an idea. Okay, how we would like to deliver the key and make sure that the key is safe. Okay, not being modified, protected, and we know that the key is public. Everybody know the key. However, to make sure that the key was not being modified before. Okay, there is some hackers has modified the value of it. So they came out with a new scheme, Diffie-Hellman. The beauty of the scheme, two parties who want to communicate secretly can agree on the symmetric key using this technique. Okay, they apply the symmetric key and then they also apply with the asymmetric key. Okay, symmetric key means the same key, and asymmetric key, which means that there are two keys, public one key that we're going to use for encryption, another key will be going to use for decryption. Okay, however, for the symmetric encryption and decryption, we're going to use the same key. Okay, so this is the example. Okay, in this example, we choose Alice and Bob. Alice A, B, Bob is B. Okay, Alice would like to communicate with Bob. Okay, anyone to agree upon a key to be used for encrypting and decrypting message that can be exchanged between them. And they would like to exchange the message. However, they would like to use a key, a public key that secure and protected. Then no one modify. Okay, there is no modification on the public key. So they say, how about we use Diffie-Hellman? First, what Alice and Bob do? Alice and Bob will agree on a one prime number. We can say it's Q. And then one root number, here we say it's alpha. Okay, in the final exam, the value, I mean that I mean not the value, I mean that the parameter will be changed. Okay, maybe they're saying that the prime number will be N, the prime number will be S, the prime number will be Q, will be R. So here in this example, we're saying that the prime number will be Q and the root number will be alpha. So these two integers need not to be kept safe. So what we can say, kalau dia kata it should be kept safe, it a public key lah. Kan? Dua-dua, both of the party, Alice and Bob, know. Okay, this value for this, each value for this parameter. Okay, both party know. Okay, they didn't hide the value of each parameter. So here, let me see, both of them already choose 11 as the prime number and 7 as the alpha number. 7 as the alpha number. Okay, so 11 equal to Q equal to 11 and alpha equal to 7. So we move to another step. What Alice do on the next step, on the second step? Alice here have to choose another private large number which is XA. So we can say that XA is a private key. Only Alice know the large prime number. The private large random number. Only Alice know. Bob will not know what is Alice's private large number, XA. And then after choose this number, random, this is a random XA number, it's calculate, okay, the value of it. Y, YA is YA, Alice, equal to alpha power by XA. Okay, XA is a private large random number that has been chosen as a private key for Alice. And then it mod by Q. Q is what? Q is the prime number that has been chosen by both of them. Okay, agreed. Because alpha and Q is a public key, public number known by each Alice and Bob. So after they replace for each value with the parameters, okay, and then they got this 7 power by 3. 3 is the XA, okay? 3 is the XA, the private large number that has been chosen by Alice, okay, as her private key. So 7 power by 3 mod by 11, 343 mod by 11, we got 2. 2 this will be sent to Bob. Okay, to the answer, this value of 2 will be sent to Bob as a public. Okay, Alice send the Y, A, okay, 2, public to Bob, which means that Bob will receive 2 from Alice. At the side of Bob, what Bob do? Bob also doing the same thing. Bob going to choose XB. XB is a private large random number that choose by Bob. Here, Bob choose 6. Okay. After that, we just replace the value for each parameter. Okay. And then we calculate it. Here, alpha and Q is the prime number. Alpha and Q is the public number that has been agreed by both party. Okay, alpha is the root number power by xb, a private large number, a private key that has been chosen by Bob, mod by Q. So 7 power by 6 mod by 11. This is the value of it, mod by 11. You got 4. So the last answer 4, okay, will be the public number that will be sent to Alice. Okay, previously Bob received number 2, and then Bob sent to Alice the value of 4 to Alice. Okay, next we move to another step. Okay, what Alice do after he received from Bob the value of 4, and Bob also received the value of 2 from Alice. By using this value and compute it with this formula, okay, 4 is the what? Using and compute it using this formula. YB is the public key that's sent by Bob, okay, and XA is the private random large number that chosen by Alice, mod by Q. So YB is 4 mod by XA. XA is what? What are the private number that chosen by Alice before? Apa dia?
3.
3, okay? 3 mod by Q. You just replace with with all the parameter with the value. You got these 64 mod by 11, and then the last answer will be 9. Okay, the output will be 9. Same goes to Bob. Bob also using this formula. However, Alice using XA, for Bob XB, because XB is a private large number that chosen by Bob. So just compute it. YA is the public numbers that has been sent to Bob by Alice. So YA is equal to 2 power by, sini ada kesalahan sedikit, jangan ikut. Okay, not 6. It should be what? Betul lah, 6 kan? Sorry. Betul. 2 power by 6 mod by 11, and then this value 64 mod by 11, you will get 9. Okay, you will get 9. So from here, what you can say from here? What you can say? This is the beautiful scheme of Diffie-Hellman. Although you are choose different kind of private key, you sharing with same public key. The public key will be what? The root number and the prime number, right? Both of the party know, and then they have their own private key. They calculate it, compute it. At the end, they got the same value 9. So it has been proved that the mechanism, the value that has been chosen by each of the person in this communication were protected, especially the key, how you would like to deliver the key. And 9 will be used as the key to what? To encrypt and decrypt. Okay, in the next process. After this, maybe they said, let's use 9 in a Julius Caesar cipher. Okay, they derive the key first to make sure that the key is protected, not being modified. After they derive the key using the Diffie-Hellman, okay, and then the key, maybe they would like to use it in another type of algorithm, RSA, Caesar cipher, real hands, and other type of algorithm. Okay, and for Diffie-Hellman is only a method that being used to deliver the key to make sure that the key that being delivered is being protected and securely. Okay, hopefully you understand. Okay, at the end, K1 must equal to K2 and equal to K. If you get another value, so there is a problem in your mathematical how you calculate, how you compute the value. So you have to check back. Okay, how you will compute. Maybe you choose the wrong value. Okay, maybe for the Q, for the prime number and for the root number. Okay, you have to check it back. Understand? Boleh ya? Setakat ni boleh faham? Okay, that's good. Clear eh? Okay. So, saya rasa itu sahajalah. Okay. Tapi saya would like to use for another example lah. Okay. This next example sama saja menggunakan Diffie-Hellman jugalah. However, using a different value of parameter. So in this example, okay, we are using P and Q also. Tengok sini, dia tak guna P and Q, dia guna G dengan P. P is the prime number, however G, previously in the example before, we using alpha as the root number. However, in here, G will be the root number and it equal to 5. So 23 and 5 will be a public number that will be known, okay, each of the parties, Alice and Bob. Okay, Bob tahu, okay, no. Okay, we are going to use 23 as P and 5 as G, the root number. So we move to the another step. Alice has to compute, Alice have to choose it private large number by its own, and it will be a private one. So here example, Alice has choose what? 6. And then compute using this mathematic formula. Okay, Y A. Okay, sorry, not Y A. Y A equal to what? 5 is the G power by N power by XA. XA is equal to 6. XA is a private secret number that chosen by Alice. Mod by the prime number 23, we got 8. This value sent to Bob. Okay, and Bob also using the same thing, the same formula, Bob has to choose a large private number that we can say is a private key. So Bob here choose 15. Okay, by using 15, compute using this mathematic formula. Okay, and the output will be 19. The value of 19 is a value that will be sent to what? To whom? To Alice. Okay, Alice will receive 19. Okay, the process was not stopped there. Both of the party have to check, okay, to make sure that is it the key is secure and protected. They have another step they must done to make sure to prove that the key is protected and secure. So what they do, they're using the each of the uh, values of number that sent by Alice and Bob, compute it with another formula. Here, what they do at Bob, at Alice, okay, calculate it. 19, okay, the number that's sent by Bob, power by 6. 6 the private large number that choose by Alice, mod by 23, it get number 2 here. And Bob, 8 power by, sorry, not 6 ni typo, it's actually 8 power by what? Sepatutnya 8 power by what?
15.
Yeah, 8 power by 15 mod by 23, you got to. At the end, the same. Okay, they get the same value. K1 equal to K2 equal to K. So it proved the key was protected. Okay, not being modified, and you can use this value of key to the next level of encryption or decryption. Okay, that is a development, very beautiful. Okay, walaupun kedua-duanya, although they do not know what the private key that has been chosen by both party, they only agree with the the prime number and the root number only. But at the end, they get the same value. This is the beautiful scheme of Diffie-Hellman. Okay, very beautiful. So I think that's all for today. Okay, I would like to share with you. So for tomorrow, we're going to have a lecture session. We're going to do some exercise, okay, to polish your skill in chapter 3, cryptography. Okay, and I will going to share you, okay, how you would like to solve the problem. Okay, and before we end our class today, I would like to ask you, do you have any question? Any question to ask? Kena ulang balik ke apa yang saya pelajar?
I do have a question, Doctor.
Yes, you have a question?
Yes, regarding the chapter 2, you see in the beginning of the session, you said there are some things that we need to focus more on chapter 2. Can you say it again?
On chapter 2. On
Yes.
chapter 2, okay, usually on the midterm test, on the final exam, when we're saying that the chapter 2, what kind of topics that we covered in chapter 2? Okay, most of the topic is theoretical. And chapter 2 is regarding what? The digital divide, right? The ethical way, unethical way, the awareness, right? And then the act. Okay, what is the law? Okay, what is the what is the law, the policy, okay, the how you differentiate between law and policy, and then what is the law and has been implemented, the act that has been implemented in Malaysia and outside there, and the others. So these two, this is covered for chapter 2.
Okay, thank you, Doctor.
Okay. So for okay, next, what you would like to ask?
Does the formula will be given in the midterm test?
Sorry, what? The formula? No, you have to remember the formula, of course.
Because it's difficult for this Diffie and RSA algorithm.
Yeah, you have to remember the formula, especially on the RSA. Okay? RSA have a lot of formula. Okay, how you would like to derive n, how you would like to derive the totalian n, and how you would like to derive the value of d. Okay,
In chapter 3, part 2, we'll focus on Diffie and RSA, yes?
on chapter 3. On
Yeah, but
chapter 3, yeah, you have to focus on both because I do not know which question will be come out for the midterm test.
no, for part 2, for what we done today.
I have already explained to you both of these algorithm, RSA
Yeah,
and Diffie-Hellman.
okay.
However, only one of them will be I will be asked will be the question in the midterm test. I do not know which one of it. You
Okay.
have to know for each of the scheme. Okay, the step for each of the algorithm. Okay, and
And
please use the how you would like to calculate the d. Please use the formula that I already
uh,
mentioned in the slide.
is
Not
it
use
allowed
the
to bring calculator, doctor?
yeah, sorry, you can use the calculator. In the midterm test, you can bring your calculator. Use the calculator. Okay?
Uh, and the last
You
question, can we write by pencil?
yes. Of course, I'm prefer used to use pen. Okay. Right now we are in a rainy day, rainy season. Okay, rainy season. What will happen if your paper has been? I mean that there is water spilled in your paper and then the what have you written can be read anymore. That's why I ask you to use pen. You can use pencil at the first. Okay, try to solve it and then write back the answer in your answer sheet. Okay, boleh. Okay.
Yeah, completely.
Okay, for the cryptography I have explained to you. Okay, there are two type of there are two main type of cryptography that we learn. The first one is classical cryptography, and the second one is modern cryptography. In your midterm test, however, okay, for the modern cryptography, we already learned two type of algorithm, RSA and Diffie-Hellman. Only one of them will be asked in your midterm test. Okay? And for the classical cryptography, we learn how many type of algorithm. We learn the Caesar cipher, Playfair, and then Virginia, real fence, and columnar transposition cipher 5. Okay, there will be only two will be asked, two or three will be asked from classical cryptography. You have to know all of it. Okay, how to apply it. However, in a admittance test, only two or three will be asked. Okay, understand? For the chapter one, I already mentioned to you. Read the computer track. Read about the what the terms that have been usually used in the computer world, like the vulnerability, like the risk, like the threat, what is reputation, and other. Okay, the terms you should know and apply where you should apply it. Okay, for the chapter 2 about the digital divide, and then regarding what the analytical tools, there are four type of four phase in the analytical tools, right? The predictive, the diagnostics, and the other two. And then about the ethical, the awareness, and then regarding what the law and ethics, and then regarding the act that we have in Malaysia and outside there. Okay, this is covered in chapter 2. Please read about it. Okay, chapter 1, chapter 2 plus equal to 25 marks, chapter 3 equal to 25 marks. So 50 will be the total mark for your midterm test.
Okay, doctor.
Yeah, there
About
will
chapter,
be three questions, three
about
main questions. Yes, yes.
chapter 3, part 1.
Sorry,
Chapter 3, part 1.
I already mentioned to you chapter 3, part 1.
Can you repeat again, doctor? Sorry.
Okay, I already mentioned to you, all of you. Okay, in the part one, okay, we learn a few type of algorithm. Okay, for the classical cryptography, right? Okay, beside you already know what is asymmetry, symmetry, and then what is a plain text, what is a ciphertext. This is a very basic one. For the algorithm, we learn about what? Caesar, we learn about Playfair, we learn about uh, Vigenère, real fans, and transposition. You have to know all of these five. In the midterm test, only two or three will be asked in the midterm test for the midterm test question. That is for the classical part, classical algorithm. For the modern cryptography, we learned just now two type of algorithm. Only one of them will be asked in your midterm test. So you have to learn it, both of it, to know about it. Okay? Don't worry, we are going to
Thank you
do
very much.
the exercise tomorrow during our lecture session. Okay? So for tomorrow, we're going to have a lecture session. The class will start at 8:30 until 10 a.m. in the morning. So hopefully all of you be punctual. Come to the class before I start the class lah. Okay, because I don't want you interrupt the class during uh, when the class already start. Okay, so that's all from me today. Hopefully all of you understand it, and we're going to meet tomorrow. Okay.
Thank you, Doctor.
Okay, welcome. Assalamualaikum everyone,
Thank you,
and
Doctor.
have a nice day. The rest of the day of you today.
Thank you,
See you
sir.
tomorrow.
Thank you, sir.
Thank you,
You're
sir.
welcome.
Thank you, sir.
You're welcome.